Alright, let's get started. I'm very happy to welcome Soroush Farrokhnia, who is a final year PhD student at the Hong Kong University of Science and Technology. He works on a wide span of things from blockchains, parametric algorithms, to verification, for program analysis, program synthesis. And with Sukriti and me, we have a collaboration already going on that part of it. But when he came here, he said he wants to talk about something else, but that was blockchains, which I think is the focus of his PhD thesis.
Yes.
And I hope we can hear more from him. He's here till Monday.
Yeah, Monday morning.
Monday morning. And so if you want to talk with him, he's in the guest house, so just fix up a time and that should be fun. All right?
Thank you. Thank you, Akshay. I'm Soroush. And in this presentation, I want to present the work that issue optimal block production revenue on Cardano. And this is a collaboration with Cardano Foundation. This is a work by my colleagues, John, Amir, Marcus, and Sergey. Marcus is from Cardano Foundation, and the other they are within the same number. And in this presentation, first I try to talk about the motivation. Then I will define the concept that's in this presentation we will call dependency-conflict graph. And then we do our problem definition, and I try to explain our algorithm. And then I will talk about our results. Okay, so in every blockchain, regardless of the consensus protocol that blockchain may use, somehow we need to pick the next miner or the next person who will decide what transaction should be included for the next block. And why do we care about this? Because we need to have the consensus on who is the next guy. Because at the end, we want to have the consensus on the order of transactions that we need to apply to the state of the transaction, to the state of the blockchain, so we get the final state. And each transaction in the classical form, we can see the transaction as simple monetary transfer. Each here, for example, I want to pay Akshay to $8, let's say. And so I create the transaction and I will broadcast transaction to everyone in the blockchain. And to hope that the next miner will see my transaction and will put my transaction in the block. And then the miner put my transaction in the block and broadcast the block to everyone, then everyone agrees, oh, my transaction is on the blockchain. So, in different blockchains, depends on the consensus protocol and their definitions. This role, the person who decides about the next block, gets different name. In Bitcoin, we used to call it the miner, but in Ethereum or Cardano, I think they use in proof of stake and they are called block producer. Or they add another layer that they have validator. But no matter how they organize it, there is always a person, a role, who will decide what should be included in the next block. And the rest of this presentation, I will call this role a miner. But again, it's about the concept. So, miner, in the mining step, every miner, they have a set of unmined transactions. So we have this transaction 1 to 6, and they are not on blockchain. So if I have a transaction which in actually to $8, nothing will still happen, right? I need a miner to pick my transaction and put it in the block. And we call this process a mining step. And what miners need to do, miners need to validate this transaction. I should not create money out of thin air. I should not spend the same code twice. So they need to validate all these rules, all these protocols. So, and this is the work. So, of course, no one do anything for free. And we need to give them some sort of reward. So they are incentivized to validate transaction and generate response. In some consensus protocols like proof of work, and Bitcoin, probably you may heard, the miners need to solve a hash puzzle. And that's a very computation-heavy thing to do. So they are interested to do this because they will get a reward, right? And we call this reward a mining reward. And to be a bit more specific, right, then miners, so I talked about some rules, but in this presentation, we're only interested in 3 rules. And just intuitively, I will explain them in more detail later, but intuitively, the miner wants to decide which transaction that they want to put in the block. They need to follow 3 rules. The obvious one is block size limit. Every transaction, it has the size. And the total size of transactions in the final block should not exceed this block size limit. And transactions, they have some relationships between each other, which in this presentation we call them dependency and conflicts. And again, intuitively, dependency means if I want to extend something, it should already be there. And conflict means I cannot extend the same thing twice. Okay, so we are interested in these protocol rules in this project in Cardano, and Cardano, it's I think it's this person is really volatile, but I think right now it's the 9th biggest cryptocurrency, and their market cap is $25 billion US. So it's something $25 billion, and they follow UTXO transaction model, which I will explain a little bit. And one thing that we are interested that they support execution of complex smart contracts. And in this, and in the Cardano, the block rewards that the miner gets, it has 2 forms. The first form is the transaction fee. So I create the transaction. I expect the miner to put my transaction in its block. So I will pay a fee to the miner. So when miner puts my transaction, they will get that fee. And the other type of reward, it's in Cardano, it's monetary expansion. And it's a reward defined by the protocol, which when miners, they mine the block if they are following every rules. And if everything is correct, they will get that money. Again, this form, the second form, like in Bitcoin, it's a bit easier. It's always a constant. In a fixed period, it will get pumped. But in Cardano, it's based on this thing and the other parts. But one thing that we care about, miner, they have almost no control on the second one. And they have control on the first one, based on the transactions that they did. So, what is our objective? As we said, we want to create an optimal Cardano blockchain block, which maximize the transaction fees that the miner gets. So I have a set of unmined transactions, and I want to pick a subset which give me the maximum transaction fee that I get. And in this project, we are interested to explore the sparsity of relationship between the transactions, as I said, the dependency and the conflicts. And we did an experiment over 50 days of blocks. In Cardano blockchain, every second we have 1 block, almost. And on average per day, we could increase the miner revenues, which they get from transaction fee, by 1,300 US.
So this is from whose point of view?
Sorry?
So who's trying to optimize this?
Miner. Yeah, miner. So miner wants to get the transactions that the sum of all transaction fees, which they put in the block, is maximized. And of course, they should follow the protocol rules, right? No conflict. And this is the revenue of miners that they get in addition to everything else if they use our algorithms. Okay. I have a question. Yes.
You said it allows for smart contracts, complex smart contracts.
Yes.
Suppose you take a buy order, buy a double options. That is, I want to buy this many shares and sell this many shares. Now, this reduces to a different problem of matching after getting it done. Execution.
Why?
Because I don't know how many shares are still pending, because I have to see what would be the possible transaction, what is the maximum match in the transaction graph, what I have obtained, and from which I can even apply the Bellman-Ford algorithm, right, to see whether what would be the most optimal one.
So I agree, this problem exists, but not from point of view of the miner. I will explain it a little bit. So In Cardano, we follow a UTXO model, and for them it's extended UTXO model because they allow the execution of smart contracts compared to Bitcoin. And in every transaction, I have a set of inputs and a set of outputs. Okay. And if let's say if I want to pay, actually again 50 ADA, I have to own at least 50 ADA from other transactions, and then I create a transaction. I set them as an input, and then I pay actually 50. And of course, I need to follow some protocol rules. I should be able to prove that, oh, I own these coins. And later, now in this section, let's say I have 50 ADA and I want to pay actually 10 ADA. What do? I create a new transaction as an input. I point back to the output that I own here, somewhere in the blockchain. And in my new transaction, I say, okay, I will pay 10 ADA to actually, and I keep for myself. And in the point of miner, when an auction is happening in the view of the smart contract, when miner sees the transaction, then someone bid in the auction. In the point of miner cannot change anything about auction. Someone is bidding on something on that auction, and they create this transaction. So all miner sees that someone doing something in that auction, and they are willing to pay me a certain amount of transaction for me to include their bidding. So if an auction is happening, right, users in that auction, it's their incentive to be able to create the transactions with high fees. So miner prefer their transaction over others. So when a miner sees a transaction, everything is deterministic. Miner knows if I include this transaction in my block, I will get this fee. Did I answer your question?
I don't know what is deterministic here.
So
naturally, there is nothing like determinism in a blockchain structure. Some fork will always happen.
Yes, I agree. So let's see this example, right? So in this example, we have a conflict. And it means that, let's say, here I have an auction, and two persons are bidding, right? And you're saying that, okay, miner should, it depends on the auction, miner should include the auction in his decision, right, when to want to bid. And transaction T2 says, okay, I bid this amount, I pay you this transaction fee, and transaction T3 say, I pay this amount. Miner, he has no control over the auction. Miner only has control to pick which one of the bids he wants to pay. And only thing that the miner will get is the transaction. So from point of view, the miner, he doesn't care what is happening in these outputs or what kind of program is running or executing. Miner knows if he includes this function call or this execution, he will get this predefined fee.
Is there a concept of gas like in Ethereum? Ethereum, like the same smart contract might execute differently depending on the state.
Yes.
For the transaction.
So they have the concept of gas, which they follow. But here in Ethereum, it's not deterministic because if you change the order, the gas will change.
Yes.
Here, how that's here when they say they have an extended model, it means they keep the state of the contract in this output. So if I have the state and the function input, then I know the output. So no matter in which order I put T2 or 3, they always use the same gas. And they calculate the fee depends on gas a bit different compared to blockchain. They care more about the size of transaction. But again, this problem, it's a bit, I will talk about Ethereum for future work, but this problem it's a bit easier compared to Ethereum because in Ethereum, if you change the order, you don't know the fee you will get because you don't know the gas. But here they keep the contract state and the contract data in these outputs. So let's go back to the definition of dependency and conflict. We say T2 depends on T1 because T2 is the spending output that exists in T1. So if I want, as a miner, if I want to include T2 in my block, T1 should already be included in the blockchain before, or I should include T2 too. Otherwise, I cannot just include T2. For the conflict, you can see the conflict that I'm claiming that I'm paying actually 10 mega and I'm paying subtracting another the same money, but I cannot do that. I cannot spend my money first. So these two transactions, they have conflict. So a miner can include only T2 or T3 in their block. Or if I'm bidding in an auction, if you have a smart contract, if two persons want to bid at the same time, one of them gets to bid and the other one should follow the previous one. Okay. I want to somehow capture this conflict and dependency. I did the graph as usual. If two transactions they are dependent on each other, if T1 and T2, then I put a direct edge between the two transactions. And if they are conflict, then I put an indirect edge or here red edges between two transactions.
That means this is conditional transaction. That is, if this happens,
Yes.
then only this will happen.
Yes.
But when you are taking the code, will it that it then will come into the picture or just a linear transactions? Linear code.
Yes.
So conditional transactions are problems in blockchain.
Miner needs to.
That is, if my salary comes, then only I have to send some 40 rupees to somebody else here. So this condition, when you code it, from the code, it will be just linear code. It will be a problem.
We will include the dependency when I'm getting my fee or salary. As you said, if I want to get the money for transaction T2, I need to include transaction T3. Right. I need to include transaction 3. Or
in Ethereum, it does not work.
In Ethereum,
because conditional transactions, when you EVM code, it becomes linear. So which one is taken is not going to be taken here. Cardano, I don't know it maybe. Ethereum is certainly it is not good. This is one of the anomalies.
Yes, in Ethereum, it's a different setting, right? Why it works in Cardano? Because in Ethereum, when you take a different transaction, the state change, right? Before executing.
It is linear, don't be assignments.
Yes.
Yeah.
But here in Cardano, right, you know your state and you're executing transaction. So imagine Ethereum. Let's say before I'm executing transaction, I can fix the word state before executing transaction. Then the settings.
So T1 is one block, time T1, and the block is set at T2, and T3 is another one. Is that correct?
No. So if
what
T1,
are T1 and T2,
so,
T3?
So no, T1 is in one block, and either T2 or T3 will be the next block.
Nothing to do with the time.
So it's to do with their order. I'm not sure what do you mean by time.
So when you take the transaction,
yes, T is transaction for T stands for transaction.
Yes, say when you take one block, it will have many transactions,
Yes.
not one transaction.
Yes.
So what do you mean by
that? Sorry, I don't
in
know.
a block, 1 mega AM, 1 MB, you have several transactions to be completed.
Okay, so
Okay. Yeah. And now that is an interval T1, T2, T3 that happens. That is the linear block.
yeah. So the difference in Ethereum, I need to execute 2, 4, 5 in sequential, right? In Ethereum, if they are not dependent on each other, as I described, then I can execute them parallel. It doesn't matter. It's
in Ethereum or in Cardano?
in Cardano, sorry, in Cardano. In Cardano, if they are not dependent on each other, then I can execute them parallel.
Depends upon each other.
Sorry.
Depends upon each other. That's what
If they are not dependent on each other, then it doesn't matter if 4 comes before 2 or 4 comes after 2. But in Ethereum, it matters. I mean, this is a bit similar to Bitcoin.
So the world state is not updated in Cardano. Is that what you're saying? I think after every transaction, you update the world state, right?
So in Ethereum, we have one single word state, which contains the state of every contract. In Cardano, I keep the contract state in each output. So I'm sure when I want to expand this output or execute this function, I don't need to know anything else. all I need to know, it's here in this output. So
after this transaction, what gets updated? Only the contract state.
So let's say here I call the function, and then the state of the contract I will put it here in this output. So as opposed if the order,
how does it construct?
sorry,
From the mempool, how does it construct the block? The miner.
from the mempool. That's what I want to explain.
Changes the Ethereum.
No, it's not exactly the same. It is the same.
How does it construct the block? The miner.
Okay, so they have a set of unmined
You
transactions.
have a mempool. From that, it has to construct based upon the space that is allocated for a block. So how does it do it?
So first, let's say he picks a set of transactions out of unmined transaction, and if they are not violating any conflict or dependency rule, then he can put the transaction in the rule. I mean, there are other protocol rules too, right? But here in this presentation, we only care about
Every block in everything has to be valid.
yes.
There is nothing
Yeah.
that one is not a possibility, but they can change the order.
Yeah, they can change the order.
And the gas price also, as you mentioned, based upon the gas price, I can choose that.
And
All these things happen in the construction of the block.
yes, but the definition of order here it's a bit different. In Ethereum, we don't know, and
Now, in Cardano, what happens? How does it construct the block?
okay, so I pick a set of transactions, right? And I know their dependency on conflict. Let's say there's no conflict, there's no dependency. Okay, nothing. They don't affect each other. It doesn't matter in which order, I can just put all of them in my block. But in Ethereum, I don't have this because I'm not sure if they are dependent on each other or not. I need to execute it, right? And it's a harder thing to do in Ethereum. Here, when order matters, then I have dependency. Here, let's say these are my transactions, and as a miner, I want to pick a subset. If I pick 2 and 3, the only thing that I need to care about 2 is 3 comes before 2 in my block. But if I pick 2 and 1, it doesn't matter. I can do 1, 2, or 2, 1.
You get the red lines, the conflict.
Yeah, red lines with conflict. It means if I pick 1 and 4, I cannot put them.
Correct. So 1 and 4 together you cannot put, 1 and 3 you cannot put.
1 and 3 I cannot put.
So
Yes.
and it is inherited through the dependency arrows. So if I pick 1 and 4, that means that I can't pick 2 and 1 also, is it?
No. Yes, you cannot pick because if you pick 2, you need to put 3, and 3 is conflict. Yes.
It's just like a database.
Yes.
So like
It's like, yes, then these are our
It's
transactions.
a database. When does database equal to blockchain? That's the basic thing.
Not always, right? I need to pick a
that's what I'm
subset.
saying.
Yeah. Or in another example, if I put 2 and if I don't put 3, then my block will be invalid. That order matters here. But then I know 2 and not 3, the difference here compared to Ethereum, that I know exactly how much gas they will use, right? Because I know the exact contract state. I don't have the order state which might change and I'm not aware. Okay, so let me move on.
Yeah, so why does a naive strategy not work? I just take the transaction and give the maximum fees, I just sort them by transaction fee, and it's straight away.
That's the greedy approach, and here we can prove this is probably the optimal way that we can get. That's a greedy approach. For example, sorry.
Yeah, so my model of blockchain is somebody does a transaction that they wait for confirmation that has happened, and then they launch a dependent transaction. It's 3 to 2. I'll probably wait for 3 to get confirmed on some block before I launch. But I'm saying in Cardano because the 1 second block time, there are a lot of interdependencies among the transactions.
So we saw a lot of interdependent, not a lot, but we saw few. Our claim here is that there are not that many, but there exist. So they make a difference. But actually, they haven't. Like in today's culture, they keep happening more because of like they create this bundle of transactions, and we can see like 2 or 3 as a bundle of transactions. That the person interested to put both of them at the same time in the blockchain. But you're right, dependency usually happens, right? We usually see conflict edges, but dependency usually happens when tree is already mined. So I don't need to care about it, but it happened in the block, but it's less purpose. Sorry. So let's do our problem definition. Given a block size limit and a finite set of unmined Cardano transaction, what I want to do, I want to create a block which fulfills all the dependency and conflicts. And the total size of the transaction is less than the block size limit, and I want to maximize my transaction fee. You're right, this is really similar to the knapsack problem, but the difference here with the classical knapsack is that the items in the knapsack, they have dependency and conflict between them. So
unfairness is part of the execution. Unfair, because you're choosing some transactions, leaving some transactions, they may not even execute eventually.
yes, and if they want their
So it's an unfair execution model.
I'm a minor, they need to
That's why I'm saying each miner has to be fair to himself rather than to the others. But fair means that's one of the challenges, right?
Yes, you're right. Some transactions they never get executed
So
because
this technically is an unfair execution.
I mean,
Order can be changed.
I mean,
I can omit something.
so
That's okay.
everything happened here. It happens within the root. We are not violating any root. We are not making any illegal move. And you're right. So actually, this is the class of attacks in blockchain. We call them front-running attacks. Right? I'm a miner. I'm a powerful team here. I have computational power, or I
Because
put
the
money.
major challenge is how the miners cannot unfairly execute. That's how even Mempool are being encrypted. That was one of the problems. That also has its own problem. That's a different issue.
Yes, you're right. It's a hard problem to solve.
Like that's where
as
the
you know.
privacy comes into the picture.
But here, the trade-off is if you want to control everything, then you have to be very careful with it, right? Because it's a hard environment to patch, right? So it will be fair for everyone. A miner can argue, oh, I'm doing all the things and you are only being fair to the users. Then I don't want to do anything at all, right? What happens here? Here, we have some portable rules and they already have this power, and we are just allowing them to make a better blocks so that they can earn more money. I mean, it's a bit unfair because I guess here we are a bit helping the big guy, not the smaller, not the users. But again, this is within the protocol rules. I mean, if a miner sort transaction by just transaction fee, again, this is unfair. If I pay more, then my transaction will get included faster. But okay, so this work is going to claim just sorting greedily will not make all the money that we can make. Should I move on? Should I move on?
Please, okay.
So the overview of our algorithms, we have dependency conflict graph, or DCG, and we want to create an optimal block. So this is proven. This is a very hard problem. Actually, this is strongly NP-hard.
So I guess even without the dependencies, it should be NP-hard, right? If you have this optimization query, I guess
Yes.
it's already NP-hard.
But yeah, it's already NP-hard. But what is proven, and I can discuss it after. It's a strongly NP-hard. So
yeah, I guess so, because it will be NP-hard because you have a subset sum reduction. But then to get strongly, I guess you need to do something.
So here, the overview of the proof is like there is a reduction from 3 sat to this problem, and the size of items and the weight is it's bounded by the size of 3 sat. So actually, I have a bound on my input, and this is a CNP.
I agree, but I guess the only question is, so even without the dependency and conflict, does it still remain strongly NP-hard?
No, I think it's big.
So strongly versus weakly.
Okay. So let's in this example, right? So the complexity of knapsack is when we do deep programming, it's and multiply by k and the number of items and k the capacity. And this is NP hard. It is strictly NP hard because if you have a cap on the capacity, if you keep the numerical value at least
the parameters.
yeah, so if you keep the if you can keep the numerical value of your variables on that, then
So this
it's
is
not hard.
you can see that the parameter value is not clear.
Yeah, but then it's strongly even if they are rounded, it's still
Also, I have just sorry for asking you many questions. The DC graph is on the possible transactions that I'm going to choose for my block. Is that correct? Yes. And so two miners can select the different ones. Yes. So it can become a flow. So now, how does this optimality? Technically, I'm not sure optimal works or only maximal works or the other. The question is that if two becomes, one of them would have to be at some point surrendered. How does it happen?
Okay, so
Is it a maximum length rule when you are merging the forks, or what is it?
So in Bitcoin, yes. So in Bitcoin, if the fork happen,
Yeah.
let's say two miner mine the same block.
Yeah,
So-
something close to that, whatever the.
Yeah, so at some point, one of them will be
Here, what-
longer than the other one, and everyone in the protocol will be the longer.
Here, what happens?
I think they are also following
The same.
the same rule. But here it's a bit different, as you
Then
know.
you can't ensure it's a maximum.
Sorry, what?
Because after goes somewhere and this one gets thrown out, and that gets become that maybe the smallest block.
Yes, you're right, but it also could be the case that your block gets mined, right? It's 50-50 chance. So you're playing that game anyway. And even though, let's say you want to say, okay, if actually we have this conversation once, let's say you want to say, okay, the network is very busy, but if I make a smaller block, then my block gets more chance to broadcast the whole network, propagating the whole network. You can still use this algorithm, you just pick the different block size limits. Right? The point of this algorithm is, let's say you fix your block size and you fix your transaction pool, and now you want to make more. I mean, I can just ask another question myself, right? That the transactions, they get propagated through network, right? And as a miner, I have the view of this transaction pool. And different miners, they have different view, right? So if a miner, again, it's not a miner. If the miner has more money, it has more connection to the network, they see more transaction. But this problem, we assume we fix first two, we fix block size limit, and we fix unmined Cardano, a set of unmined transaction. And now I want to pick a subset of them, which I can prove that makes the most money that I can make. Did I continue? So, again, this knapsack, it's a strong DNP hard. What we do here, what you're interested in my group, here we want to start, and so we have an intuition, and the intuition is just blockchain is very big, and these conflicts and dependency, they don't have that much. But we want to somehow capture this formally. In this work, we try to capture it with a parameter that we call treedepth. And I will explain it in more detail, but in general, I want to formally capture how star-like these graphs are. And if the treedepth, if the parameter has a small value, then I can come up with a polynomial-time algorithm, which works fast. And why I'm interested in this, the above row, it's not efficient on practice, but finding this decomposition, this is still an NPR problem, but this is efficient on practice. And then, sorry, here, the next algorithm based on the treedepth decomposition, then it's a polynomial algorithm, then it's also fast. So, and I can do the whole pipeline within 1 second, which is the Cardano area between two points. And it was, so we are comparing, and Cardano is a bit harder compared to Ethereum and Bitcoin, because for Bitcoin we have 10 minutes, and for Ethereum we have 12 seconds on average. But here we have 1 second. So it's important that we able to do everything within 1 second or less than that. So
Is the graph practice?
sorry?
How long is the graph practice?
I don't have the number here, but I will give you an step which will give you an idea of it.
I think this is hundreds, thousands, millions. That's scale here.
No. It's different, definitely conflict. So just if I want to give you an intuition, so these graphs they don't get big because we have a smaller block area Cardano. So the set of unmined transactions,
So this.
yeah, it's relatively small, but again you have less time to do your process.
So if you're going to address this, you can take it later. But why treedepth? Why not treedepth and other classical things?
We found so the treedepth was a smaller here. And we wanted to check, actually, one of the reasons we want to check a new parameter and to see if it works. And the algorithm that we found.
Do I mean that, does it mean that you also tried treedepth and other things and they didn't work if this works?
No, we didn't try that. But we found out we have a good algorithm which has a good dependency on the treedepth compared to treedepth on the passive.
For the first one.
Yeah, for the first one. And when I say the complexity, then it kind of makes sense. The three paths and the three paths and three parameters, they have a higher constant depends on the pathway than the three bits. Okay, so how much time do we have? Okay. What?
20 minutes.
Okay. So. What is the tree decomposition? Tree decomposition, if I have an original graph, it's just rearrange of the original vertices in my original graph in a way that all the edges that happen in the original graph, they have ancestor and descendants relationship in my tree decomposition. And this is really nice for me because whenever I want to check constraint for one vertex, I need to check the ancestors and the descendants. So each graph has different tree decompositions. And here this is not the correct graph because there is an edge happening in this one which does not have descendants and ancestor relationship. A bit more formal, tree decomposition is the rooted tree T over my original graph, V and E, which every edge belongs to E, it's either an ancestor of E or the vice versa. And treedepths intuitively measure graph sparsity or how shallow my graph is or how star-like my graph is. And the treedepths or the parameter treedepths for each graph is among all the possible treedepths decompositions, I pick the smallest one. And for example, in this example, it's 3. So, and now I have a decomposition of my original dependency conflict graph. And this is the treedepth decomposition, all the edges that are happening in the original, its ancestor and descendants. And now I want to design a DP algorithm over my graph, which traverses vertices in my treedepth decomposition or in my tree. I will call it tree. That at the end I will get what I'm looking for, the maximum total fee. And here by Vi I mean set of vertices until I, and I'm traversing my tree with DFS order. So 1, 2, 3, 4, 5. And a TX star is a set of transactions that I will decide to include in my block at this point. And the DP is similar to knapsack in a sense that in knapsack in DP you have I, the item, and the C capacity. Here we have a new variable in our DP, which is a solution S, which is a subset of ancestors of transaction I that I decide to include in my block. And I will explain this more. But whenever I want to update my DP variable, I need to make sure that the total time, I need to again keep making sure that the protocol rules will follow, that the total size will not exceed my capacity and dependency and conflicts are satisfied. And the main group, the general idea of how I will fill this DP, again, I will start traversing my vertices in DFS order multiplies plus treedepth. And step by step, I will update my DP variable until I reach my last vertices. And okay, let's see how we initialize our DP for the first vertices. Here, let's say I only have vertex 1. And for vertex 1, I have two choices. Either I will include it or I will not include it. Or in another word, the set of ancestors for vertex 1, it's either empty or it's contain 1. If it's empty, it means that I'm deciding that I will not include vertex 1 in my final block, and I don't get the fee. If I decide to include, so here S is just contains 1. If I decide to include, I get the fee if the size constraint is not violated, and I will put like whether DP is minus infinity whenever something is wrong or some rules are violated. So the initialization of my DP for the vertex 1, it's a bit straightforward. I only have two cases to take care. Now let's say I want to fill the DP variables for vertex 4. What I need to do, I need to go through all the solutions for the subset of the ancestors of 4 and check if they are violating any portable rules or not. And the treedepth decomposition in this sense is really nice. Why? Because as I said, every edge that happened in the original graph will have descendant and ancestor relationship here. So here I can set a solution which only includes 4. I cannot put it because 4 depends on 2. So this is a wrong subset. The next subset that I will check is 4 and 2. This is correct because I'm not doing anything in conflict and the dependencies it's here. If I decide to put 4 and 1, then they are in conflict. Then I cannot put this subset of my ancestors in the final block. And if I decide to put all of them, then again, I'm still, even though that I'm following this dependency, I'm violating this conflict. So I cannot put this subset. So at every step for vertex I, I'm going to check all the possible ancestors. And update my DP variable based on the subset that I'm checking. So again, we set minus infinity whenever I'm violating some rules here. If I see if solution set, which is the subset of ancestors, if it's violating some dependency violation, then I simply put minus infinity for this variable. And if it's violating some conflict, I put minus infinity again. And now let's see how we can update the DP variable if I'm not violating any rule. And for two variable, I have a set of for a variable 4, I can define a set of ancestors, and I can, which here I said it's 80. And for a set of common ancestors between two vertices, here it's again it's a set of common ancestors. And why do I care about this? Because if a solution S for vertex I is not violating any rule, then I want to update it based on my previous step in my DP. And what I do, I go through all the compatible solutions in the previous step. And what do I mean by compatible? It means that they make the same decision about their common ancestors. For example, here, if I'm updating 6 based on 5, if 6 decides to put 1 in the final block, which it always should do, then I'm checking the DP variable for 5. I need to check all the subsets that which make the same decision about 1. And of course, I have two possible choice for each solution. Either I'm putting the transaction or I'm not. If solution S does not contain vertex I, it means that I only need to get the maximum of DP variables from previous state, which again compatible. They are compatible with my current instance. This is my current solution. And if the current solution contains my vertex I, I get the fee for vertex I, but I need to pay by the size of transaction I. So I go through all compatible solutions from previous set, and I get the maximum over them. And the final solution comes when we start from vertex 7 here, and we go through all the subsets, all the solution, all the subsets of access to vertex 7, and get the maximum over them. And this is how we update RDP. Again, intuitively, we traverse our graph over vertices in DFS order, and we care about this subset of ancestors that I'm putting in my graph. And this is very nice in treedepth decomposition because I need to only check the ancestor relationship because every edge should happen until from my ancestors. Okay, so I think more interesting part, we did a benchmark over 50 days, over 2,000 and 1,100 blocks. And as you can see, the treedepths, at least in this period, is bounded. The maximum that we saw was 6, and the average is 45. This means that if the treedepth is 2, it means at least one conflict or one dependency there. And if it's 6, it means that I have a more complicated graph, which has conflicts and dependency. So you see, they happen, but there are less frequent as we assume, and that's your hope that we can capture. And so we managed to improve transaction fees over 56,000 blocks among 20 to 111,000 blocks. And to answer your question that we said, transaction pool, are they big enough for how many transactions that they have? So mostly they would improve if they have a transaction pool which had more transactions than block size, right? So sometimes because their blocks is very frequent, sometimes I have like 2 transactions and I will put those 2 transactions per block. So I couldn't improve anything in that case. But I could improve 56,000 blocks.
They're already mined blocks or?
Yes, they are already mined blocks.
But they don't conflict when you're already mined.
No, I assume in this experiment, I assume I'm the miner, and I just wanted to know if I had this algorithm, if miner had my algorithm, how much people get. No, we didn't put these blocks on chain, right? This is just comparing the. So I mined the block again. I didn't put the new block on the blockchain because it has conflict. Yeah, this is observing. Again, this is the potential money. I don't have conflict with you.
It's not real money, otherwise you would not be able to talk to it.
I mean, yeah, it's a potential revenue.
Improvement based on which algorithm are you comparing to your the base, the miner.
So miners, they have their heuristics, they have their algorithm that we are not aware of, but we know their decision. What transaction page is such a good industry. Yeah. So it's a real one. So we saw their decision, and it's our decision, and then we saw, oh, okay, and the overall improvement. This conversation is not correct.
That is kind of like that code is stupid miners.
Sorry, what?
So in the history, I mean, so in some sense you are kind of just, I don't know. So this is just over everybody in the world. So you are in some sense in the stock market, everybody loses. What's wrong?
Now, how much of that is a useful one? Because when the fork happens, that money what has paid is only earned rather than given. So technically, it's only a part of it means. Because if you analyze the whole transactions over a 50-day period, some of them may be incompleted, some of them maybe 8% will be forked. And all this, if you take that into account, you can say how much is the real benefit and also to the whole platform, how much is the cost.
So this is not the case for Cardano. In Cardano, they use proof of stake, and before and the fork begin, for each block, they say, okay, this block belongs to this person. Still, a fork can happen, but it cannot happen by 2 persons. One person can create a fork which is not in their incentive. Create and bad block and good block and hoping the good block. So the formula.
Is it the aim that each miner has to optimize its fees, or where it is used?
Sorry, can you?
Is it the objective in Cardano? Each miner will optimize his transaction fees.
It's their incentive.
That is something I have not seen in a blockchain world. That's why.
I mean,
Because it's an unfair one, right? That's where the whole thing is.
this is already happening in Bitcoin and Ethereum, and I will talk about EVM shortly. Not EVM. I will talk about MEV, as you probably know, right? And I will say, okay, a lot more unfair thing is happening in the blockchain. But in this case, the fork will not happen. So if they used our algorithm, they would earn this much. If you apply the same algorithm in Bitcoin, then you're right. It could be the case that two persons are competing for the same slide, and if your block may not get your block.
Experiment, you also captured the mempool just before the block was mined.
So mempool was provided by Cardano Foundation. They captured, they have node, and they captured the mempool. And to be more fair, because it could be the case that we have a different view, right, from miners. So we try to somehow make it a bit more fair, right? And by assuming that we have same set of transactions.
I think one step, because if I apply your algorithm, then it's a different block.
Yes.
Then I'm comparing the revenue increase, that modified block or the actual block which came on the.
So we applied our algorithm, and we have the new block, and we already have the original block.
Yeah.
We compare the revenue.
Okay. For the next block, what do you
Again, we have
mempool?
the mempool and the block.
So the abstract to work with for transition is that for a given transition there are a set of metrics and there are a set of dependencies. This is the only things that the miner has to keep in mind, or are there more things that an actual miner would have to keep in mind when selecting a block?
I strongly advise begins, but we can always bribe miner directly. And that's actually what is happening. There were some transactions that we didn't see in mempool. It means that I know you personally, not you. I know you personally, and I gave my transaction to you, and ask you to put my transaction. And of course, you will only do this if I bribe. But don't do it. You should not do anything that I'm suggesting here.
But let's suppose it's happening every second. There's a lot of space left, right?
Yes.
Which cannot necessarily be without any cost of the mine.
Yes, but sometimes, for example, that you're sure, right? If the miner has no choice, it will give you a transaction. But let's say, actually, this happens a lot with these mean points. Again, don't buy them. I strongly advise you against buying them. Don't do it. But in a short period of time, let's say I create a coin Soroush, and I say, okay, only 100 coin exists. And in the short period of time, that which actually happened here, you need to compete. Either I need to increase gas fee, which might be the case that miners say, okay, this is not enough, or I directly bribe it with my transaction. Because I believe that might will have most my money. I will show MEV a little bit later, but just sorry. The average improvement was $1 per block, and the potential annual improvement is nothing.
So it's I don't really know a lot about blockchain, so this crowd may be a bit weird, but they just reset my initial diagram. Are there other factors to transaction, for example, the difficulty of a transaction or the amount of computing power required to do a transaction, which, for example, this model does not take into account? Yes, miner would have to take into account.
So here, I pay a fee to miner, right? If I know that my transaction is computationally heavy, if I don't give you enough fee, then miner says, if your transaction is computationally heavy, it affects both parameters. First, you need to pay more fee based on the protocol definition, and the size of transaction is bigger because you may save more data and stuff like that. So miners has to work with that. But the good thing here with Cardano is miner knows those values in advance, which is not the case. And of course, they need to follow different protocol rules, but they all happen before they validating the ones. validating transactions. Okay, and in conclusion, algorithm is probably optimal. It's almost polynomial-time. It still depends on the size of the upside, but except this for me. And then we increase the miners revenue by $500,000 there, and the tool is available online.
I guess you should qualify it, right? All the time assuming that the treedepth is small.
Yeah. Assuming the treedepth is valid.
Yeah.
How old is this one? Minus have adopted this.
I mean, this work is old enough that when I started, the market cap was 60 billion. Now it's 25. So this is more than $500,000.
Okay.
But again, it's very volatile. Like next month, it could be the case that this work is worthless, or that just blockchain went out of money. Don't do it. Don't try. It's just my reservation.
So I think you said that each transaction effectively has a deterministic transaction fee, right? So effectively, yeah, if one guy runs the algorithm and another guy doesn't, then the guy running the algorithm makes money at the expense of the other miners or not. But eventually all the transactions get into the total transaction fees on all miners is given, it's sort of like fixed. It's just that somebody who's more clever might steal the money from the other guys in some sense.
That's the case, but not always. So when you have a conflict between two transactions, if I put one transaction and I leave the order,
So some might
no one can put that transaction in the order.
Some get eliminated.
some get eliminated.
And what is the future work? Future work is to adopt this for Ethereum. As you all said, Ethereum is a lot harder because here I know the value for my fee and sizes. In Ethereum, we don't know. In Ethereum, we have gas, and the gas usage may vary if you change the order, even if you know the dependency. So you don't know the date of your items, you don't know the value of items, and you need to work with a lot more transactions because Ethereum is more easy. We were working on the Ethereum case, and we had some breakthrough. Unfortunately, not very true because everything is very crowded. Like if you have these big rates, especially when it was for studios election.
How can you talk of this? Because they can reject it if the gas price is less than what they want. Unless you increase it, they may not execute. There, in my view, it is not as if they want to execute a lot of transactions. Increase the gas, and then they will execute. Otherwise, they will put it in the downward in the stack.
That's one point of view.
That's the way the Ethereum works, right?
Yes, but let's say you will have a couple of transactions and everyone increasing the gas price, right? So increase the transaction. You still have
This
this
will work
problem.
only for database on which you can update the conflict type. I think one of the former PhD students who works in IBM research has compared the database control with respect to the blockchain transactions. He has constructed some of these data graphs and things like that.
You're right. The hardest part in Ethereum to actually find these agents, right? Let's say I know I can give you a guarantee. I have to a smart contract and they will not bother each other. Then you know if you put this transaction of the first contract before or after the second smart contract, it will not change it. Right? If I can give you a formal guarantee, but you know for sure these two codes they don't affect each other. But we don't know this, and it's only decidable in Ethereum because we have the gas limit or block size limit. Otherwise, it's undecidable. Yeah. What we did in Ethereum, we found, up to now, we found a good way or good heuristic to encode our problem into items. And again, and another problem here is MEVs. And what are MEVs, which probably you should know. That we have this liquidity pool on blockchain and they act as an exchange, right? And if I know two exchange and they have a different exchange rate, then I can If I really fast buy something here and sell something here, then I will make money. And if I make a bundle of my transaction, then I make money. And on Ethereum now, everyone, they are bribing miners for these MEV transactions. And basically, that's a big problem. Okay. So thank you for listening to my talk. I hope.
Thanks a lot. We already had many questions, I think, throughout the talk. So let's maybe wind up now. But as I said, Soroush is around till Monday. So please feel free to fix a meeting or something. I think he's sitting at CFDBS, CC 2301. So if you want to earn some money, you can get advice.
Actually, we asked the lawyer, am I legally need to say, I'm not suggesting anyone to buy anything here. That's the seminar, and actually, just for you, that's the place.
Oh, yeah, I wanted to ask you this. Yes.
So this is my DP variables, and 2 to the power of these because I have 2 to the power of the answer source, and this is the chicken.
Yeah, but yes, that is.
Okay. And again, this is better because if the passes and the tree is covered, this value is much higher. Depends on the value. Be careful us once again. Thank you again.
Thanks.
Yeah, thanks. This was a lot of questions.
I have a few other questions.
I think he asked for the website, right? If we get done.
I like to help miners get Thank you. Again, if you want to talk, or even a lot more problems,